Hi everyone, this is Shannon Williams from Rancher Labs. Thanks so much for joining us today for our October online meetup. We're going to be talking today about container monitoring. And it looks like we're going to have a great crowd. We've got a ton of people registered for this, so it looks like a very exciting topic for lots of people that are interested in learning about. So just a couple quick introductions. For those of you who haven't joined one of our monthly meetups before, I'm Shannon Williams. I'm one of the co-founders of Rancher, and we host these meetups every month. Darren and I have been hosting them. You can find all the old recordings on our website under events. But we've been hosting these and covering different aspects of container management, from how to handle logging to how to deploy applications and do scheduling, and how to integrate with your CI system. And today we're really excited to dig into monitoring. And to do that, we're gonna go through a number of presentations. We're joined by three people who are going to be presenting today. I'll let them all say hello as we go through. But one of them you may have met before on one of our earlier meetups. Bill Maxwell is our principal DevOps engineer here at Rancher, and he'll be talking today about his use of monitoring around Docker containers. Bill, you want to say hi?
Hi, everyone.
And we're also joined today by two of the key people at Sysdig. So Chris Crane is the VP of Product, and Gianluca Borello is a senior software engineer there. And they're going to be digging into a lot of data and information about how they recommend monitoring platforms that rely on Docker. Chris, Gianluca, you want to just say hello and introduce yourselves?
Yeah, thanks for inviting us here today, Shannon. We're really excited to be here and looking forward to digging into some monitoring stuff.
Brilliant, thanks, Chris. And Gianluca, you'll notice, is the other person on the other end. If you hear someone with an Italian accent, you can be safe to assume that's Gianluca. So, all right, guys, we're going to get started. Before we get going too fast, I just wanted to, kind of anyone who this is your first time attending one of these, we do try to run these a little different than the classic online webinars. So we've built this program as a meetup. It's designed to be very interactive, to be very informal, and also to focus on technology as opposed to a bunch of marketing pitches. So what that means is, these tend to run long. We don't have a fixed deadline and a time where we shoot to get everything finished by. I don't think we've ever finished one in an hour. So, be prepared. The meetup may go for an hour, may go for an hour and a half. Sometimes we've even gone longer than that. And the reason is we take questions as you have them. We spend a lot of time demoing and showing things, and that means if while we're demoing something you say, well, how does that other thing work over there? We try to answer those questions as they come in. So, we understand obviously everyone doesn't have all the time in the world to attend, so we record these meetups and we post them online afterwards. So hopefully, if for any reason you do need to leave, you can always go back. We'll send out an email with a link to the recording, and you can capture that later. As I said, questions are always welcome, and on that note, in the GoToWebinar platform, there is a questions pull-out. So if you kind of look at the sidebar here, you should be able to find a questions tab, and that questions tab will allow you to easily post your questions. Feel free to mention if you're comfortable asking your question out loud. Sometimes we'll unmute people's lines and let them discuss it. But we'll try to answer every question that gets posted either directly out loud, or we'll respond through the app if for some reason we're going to cover the topic later on in the course of the meetup. So other things to just think about in terms of what we're doing is this is meant to be collaborative. So if you're on Twitter and you want to get involved in the conversation, we have a hashtag Rancher Meetup that we use for every one of these. People love to post photos of how they're watching and where they're at in the world watching the meetup. They love to kind of push, kind of talk to each other and meet each other. So if you're on Twitter and you want to talk with people while we're talking and question our assumptions, feel free. We'll always try to respond if you ask questions on there after the meetup and we don't get a chance to answer them now. So use that hashtag if you want to get in touch with anybody while we're chatting. Okay, so for today's agenda, we wanted to cover a number of things. We're going to go through a couple of quick introductory overview slides about Rancher and Sysdig for people who haven't either used or are not familiar with the products and the companies and the platforms that we will be talking about. But those should be pretty quick. I'm going to talk a little bit about Rancher. Chris is going to talk a little bit about Sysdig and really dive into some of the unique challenges of container monitoring. Then we're going to switch to Bill, and Bill is going to really talk through his experience deploying and monitoring Docker applications using different tools, some of the unique requirements around monitoring of containers versus VMs, and he'll take through that, and then he'll go through a full demonstration of how to deploy your applications, deploy monitoring stacks, use those monitoring stacks to do things like tell you when you need to add more capacity or deploy more containers. Once Bill wraps up, Gianluca is going to jump in, and Gianluca is going to dive into really the deep elements of monitoring containers on their own. So he's going to look kind of at the concept of local monitoring. What do you do on a single host, or to look at a set of containers and what's happening there. He's going to go through some of the cooler things you can uncover by doing that. Finally, Chris is going to demo the Sysdig cloud and show the platform that Sysdig has developed for monitoring a very distributed set of infrastructure services. So Bill will cover it a little bit because Bill and the team here at Rancher are using Sysdig, so he's going to talk about how they use it, and then Chris will show it to us in a little more depth and also talk a little bit about the roadmap and point out some things that are coming. Then we always wrap these up the same way. We'll give you some quick updates on the latest features we've added into Rancher or Rancher OS, and we'll point out to you how to get started with all these tools and how to set up and download things. So should be a really dense meetup. We've got a lot of content to cover, so hopefully we'll keep a good pace going and not bog down too much. All right, so let me start with just a bit of introduction for those of you who aren't familiar with Rancher. Rancher is an open source product that is used for people who want to build their own private container service. And when we talk about a private container service, we're talking about effectively an implementation of software that is similar to Amazon's EC2 container service or Google's container engine, and that it orchestrates and manages the deployment of your container environment, but does it instead of against a single cloud across any infrastructure anywhere. So it's an infrastructure and orchestration platform for Docker. And what that means is that we basically are tying together computing resources from any cloud, any virtual environment, any physical host with orchestration software that includes Docker's Compose and Swarm, as well as Kubernetes, and making that available to teams so that within your organization you can deploy a service that any team can access and build up an environment and start deploying and managing containers on. That then is plugged into by all sorts of different DevOps tools that can talk natively to Docker. So under the cover, to do all of that, we implement the Docker API for these tools to talk to, as well as a number of infrastructure services such as container networking, load balancing, storage, service discovery, for managing and deploying those containers and making that infrastructure function consistent regardless of where you deploy. Meaning that if you deploy on Amazon, your experience will be the same for deploying your containerized application as if you're deploying in Google or on a cluster of bare metal infrastructure. So when people roll out Rancher, they tend to deploy it as a container service that plugs into their Ldap or AD or some type of user directory, like even just a GitHub auth system, so that users can then spin up environments, populate them with resources from any cloud, connect to their registry and start deploying individual containers onto those hosts or entire clusters or even complex blueprints like a Docker Compose file, and then bring in users, other partners or collaborators to manage and access that environment. And when they need to spin up a different environment for, say, testing, or for another team, maybe that team can deploy their environment and choose to use instead something like Kubernetes to manage their environment. Inside each of these environments, though, the real power of Rancher is what it's doing to consume these different hosts from different platforms and implement the applications with consistent networking between the containers, service discovery for the different services and allowing them to find each other, and for the application to span across an entire cluster, load balancing for managing containers at a load balancer level, and health checks to maintain the health and viability of the services you're launching, all of which gets then exposed using either the native Docker CLI, Docker Compose, and Kubernetes. So that's really, at a high level, what we're doing with Rancher. I want to turn it over now to Chris to talk about Sysdig and just introduce a little bit about where the team has come from, how they are deploying, how they're building out container monitoring technology. And Chris, I'm going to pass the ball over to you now. You should be the presenter momentarily. There you go.
Yep, looks like it came through. Get my slides going. All right, so hopefully this is coming through. Thanks again to everyone for joining today. Thank you, Shannon. Again, my name is Chris. I run product here at Sysdig. Quick introduction. Here at Sysdig, we build monitoring and visibility tools, and we really specialize in Docker and containerized environments. We have an open source tool called Sysdig, which is used for really deep system exploration and visibility, particularly within containers on any Linux-based operating system. That open source tool is used by hundreds of thousands of people around the world today to get visibility into their Linux systems. And then on top of that core open source technology, we've built Sysdig Cloud, which is a full-blown monitoring, alerting, and troubleshooting platform. And as you can see here, we really believe it's the first and only container-native monitoring solution. So I'm going to get into what that means a little bit more here, and later today I'm going to pass it off to Gianluca to really talk about the value of the core technology and the open source tool. But first, I just wanted to kick this off with a kind of introduction to the types of problems that we're seeing as we're talking to people who are deploying containers in production, trying to get visibility into them, and our take on how you can kind of go about addressing those challenges. Obviously, it's a topic that we think a lot about and is really important to us. So to kick it off, hopefully I'm preaching to the choir on this with the audience on this call, but we think containers are great, and they really deliver a lot of value, and that stems from a couple different sources of benefits. The first and maybe original value of containers is that they're really lightweight and they're really efficient. They eliminate all this overhead that you have with virtual machines and allow you to optimize your resource utilization. From that, though, you also get that containers are really dynamic, so they can spin up and down really fast. You can very easily and quickly create dev or staging environments or highly scaled environments, and even in production, you can scale up and down really quickly and create very dynamic, elastic production environments. And then finally, and I think maybe most importantly, containers have this added benefit of being very reproducible and very portable. So you wrap up your application in this container, and then you can transport it between different environments, and at least in theory, that application should behave the same way in each of those environments, and without all the challenges brought about by having different dependencies in different environments. So you can move containers between different environments in the software development lifecycle, so going from dev to QA to staging to test to production, or even between different organizations' environments by pulling down containers from a public registry. What all this really leads to is I think containers are enabling these big movements which are generating business value for companies, things like DevOps, things like moving towards microservice-oriented architectures. Now, of course, there's a catch. With all of these benefits come some challenges, and in particular, seeing inside of containers is really hard. So why exactly is that? Why is visibility so hard in the container world? There are a couple reasons which many of you may have experienced firsthand already. The first is just the complexity that comes from running a containerized environment. With all these benefits and value that gets kind of delivered to the end user of the containerized infrastructure, that kind of comes at a cost to the teams of people who have to manage that infrastructure because of all the added complexity. You've got exponentially more number of nodes and larger environments where you had dozens of VMs, you have hundreds of containers, or whatever your scale is. It's easily 10x more with containers. It's moving way faster, containers going up and down in seconds instead of minutes or hours. And on top of that, you've got all these new container native technologies, this whole ecosystem of scheduling and orchestration tools and all the other tools that are evolving and popping up around Docker, Rancher being one of them, which add all this awesome extra value. On top of that, also bring in new technologies that need to be monitored and that you're going to want to have visibility into in your production environment. And then finally, there's just this, the kind of the inherent fact containers are black boxes. They're designed to isolate the processes inside them and the applications and running inside them. So when we kind of looked at all this, we realized that it creates this catch-22, and we've talked to a lot of users who are experiencing this, where you're stuck in this challenge where you want to innovate your infrastructure, you want to evolve towards a microservices-oriented architecture, but it comes at the cost of visibility. And of course, visibility is really important, probably even more now than ever with this extra complexity. So we started asking this question: how can we enable people to utilize these new technologies and evolve their infrastructures without sacrificing visibility? And this is really the core of our mission and our vision as a company, and why we founded Sysdig, and all the technology that we're developing is trying to address that challenge and help people solve that. So when we started looking at this challenge and how we could develop some core technology that would enable people to actually get visibility into containers, we first looked at kind of the existing methods for getting visibility into containers. And I know Bill is going to touch on this in a little bit more detail later as a real user of these technologies, but I wanted to kind of quickly give Sysdig's take on this. There are three real options. The first is you can dive into the containers and just execute commands from inside of them, similar to SSHing into a VM in production and running command line tools there. This may work well in a dev environment. This does get you visibility inside of the container, of course, but this is really impractical to scale. Doesn't really work as a production monitoring tool, and it's pretty dangerous to do in production as well. On top of that, most containers don't contain a lot of the Linux tools that you're used to using in a VM, and Gianluca will touch on that a little later. Second, you can take the agent, the old virtual machine agent that's worked well for 10, 20 years now as kind of a method for monitoring production nodes, and it works great in VMs, right? You've got this small piece of software you installed on the VM. It's low overhead. It's easy to run. It can see everything running on the virtual machine. It can pull your application metrics. It can pull your network metrics, your system metrics, and kind of everything is great. So what happens if you take that virtual machine agent and try and run it inside of a container? Well, again, this is good because the container is not a black box. You actually see what's running in it. The problem is that agent is used to running on a VM, and it's going to treat the container as a VM. So suddenly you've got all this extra overhead on the container. You've got a bunch of management overhead. You've got resource utilization overhead. You've got all these dependencies that you're trying to pack into your container and making it no longer as portable and reproducible as it used to be. Really what you're doing is defeating the whole purpose of the container. You're breaking the core philosophy of container with this idea of running one process per container. So we really suggest you avoid this method. The third method then is to take your VM agent and install it outside of your containers, either directly on the host machine or in another container itself. This is definitely a better method because you're at least respecting the sanctity of your containers, if you will, and letting them run as they're supposed to. The problem is your containers are back to being black boxes now. So you can get some metrics out using the tools like the Docker Stats API, which can export basic system metrics. But for the most part, you're not going to be able to see what's going on in the container without a really heavy amount of configuration to be able to plug in that agent into what is essentially a separate machine for it in order to be able to extract those application metrics, and it ends up being really brittle and breaking pretty easily. So, so what do we do at Sysdig? Well, we developed a core technology that we call container vision, and we've got kind of a basic architecture diagram of what it is here. But what we really tried to do was get the best of both worlds, or the best of all worlds. And what it comes down to is we want to give you visibility inside of all of your containers, but do it from outside the container. And no matter what monitoring tool you look for, I really suggest that you look for these kind of attributes in your monitoring tool for a containerized environment. We call monitoring as a microservice because essentially what happens is your monitoring is deployed as a microservice alongside all the other microservices that you're running in containers. So you just drop the Sysdig Cloud Container Vision container into your environment. It runs alongside all of your other containers, and we're automatically going to detect what technologies and what applications are running in those other containers, automatically tap into them and start extracting metrics. So what it ends up with is that you get all your application metrics again, you get all your infrastructure metrics, all your network metrics, everything that you're used to from a really cutting-edge monitoring system in a virtualized world, you're now able to get it in a containerized world. But you're able to do it in a way that respects those core tenets of a container and lets you get all the benefits from those containers. On top of that, you can see the arrows going down. We're also going to integrate with all of your orchestration and tooling on all the other container technologies you're using, as well as give you really deep visibility into the host operating system in the network. And that's all coming from our open source technology, which Gianluca will touch on in a bit. So just to kind of summarize here, why monitoring as a microservice, and this is really what you should be looking for in a monitoring tool for a containerized environment, or at least what we suggest. At the highest level, again, it aligns with these microservices principles, running one process per container, letting those containers be pure and reproducible, and without having to pack extra stuff into them. Maybe most importantly, getting full visibility into containers, so everything that you expect from your virtualized environment, you're going to want that when you go to containers. So application, infrastructure, system, network. You want that support for all the other ecosystem technology that you're going to be using, all your orchestration tools, your management tools, your cloud container tools. And you want it to really match with the direction you're probably going with your production infrastructure, which is making it highly scalable and highly dynamic. And in order to do that, you really want to make sure that there's very little, or if possible, zero setup and zero configuration needed on an ongoing basis as you're spinning containers up and down. I'm gonna wrap up here, but just Sysdig Cloud in a nutshell. What do we think we can offer you? Well, we think it's cutting-edge monitoring and alerting, so a best-in-class monitoring, dashboarding, alerting, troubleshooting, everything you expect from a monitoring tool, plus a ton of unique features on top of that, which we'll get into in a little bit, things like topology views, things like real-time data. And we're going to deliver all of this as monitoring as a microservice. So just another microservice you run along with everything else in your service-oriented architecture, just a container you drop into your environment and everything works from there. And I know this call is mostly focused on monitoring containers, but it's worth noting that all of our technology, everything you get from Sysdig, is going to work in non-containerized environments as well as maybe most importantly, hybrid or transitional environments. So if you're moving towards containers but aren't fully there yet, going in stages, which I highly recommend, we'll still be able to cover your entire environment for you. So on that note, I'm going to pass it off to Bill, or if there are any questions, feel free to throw them out there. And I'm really excited to let Bill talk now, because Bill and Rancher were one of our earliest and now one of our favorite actual customers of Sysdig Cloud and users of Sysdig Cloud. So I'm excited to let him tell you a little bit about this from maybe a less biased perspective, but as an actual user of these technologies and containers.
Thanks, Chris. Yeah, thanks a lot. That was very helpful. And next, Bill's going to walk through his setup. Bill, you should have the ball and be ready to present.
Yep. Can you see my slides? Great.
Yes.
Cool. So we're going to start just diving into kind of monitoring containers. Chris sort of already touched on a few of these, but we'll go into them a little bit deeper. And sort of kind of in the server world, kind of your parallel, you had your monitoring agent, maybe you're using Nagios or Sensu or something and kind of monitoring there. And then you have stats agents. You're shoving Graphite, Statsd, all sorts of stats over to a stats engine, which feeds kind of into this centralized analyzing service, which then kind of feeds out alerts and monitoring dashboards so that users can kind of watch and take action, about what's happening in your environment and kind of, get visibility. In some cases, logging is sort of part of this as well, but we're not really going to touch on it in this meetup. And so there's a couple different approaches, problems that come up with containers now. You have a bunch of containers on a box, and they're somewhat opaque, just from a, tying the metadata, what's happening on the OS to the metadata that's in the container. So you can see the processes, you can see kind of like a bunch of stuff just on the box, but you can't really tie it to like the application in the container. And then the other interesting thing is they're ephemeral, they come, they go, they're really fast, and how do you kind of keep track of that? And then, if you have stats, where do you send them? Localhost in a container isn't necessarily localhost on the box that's actually your stats agent's listening to. So there's just a lot of different considerations and challenges that arise from a containerized environment. So there's a couple different approaches. You can put like a stats collector in each container, or mount into like a sidekick pattern so that you're only running one process. You can create a single container that everyone links to and sends their configuration or their monitoring information there. Then there's host agents that are container aware. You can kind of correlate container metadata to process metadata and get visibility into the containers that way. And so in a collector in each container, you basically are duplicating the collector in every container, either through a sidekick or another process running in the container. This is nice because you get container level stats. If you have multiple application teams in a trusted environment that are deploying in the same space, you can kind of allow those teams to pick the tools that they'd like. But you end up with the management overhead of adding those containers, the resources of running multiple different agents or collectors, and then if you're running multiple processes in a container, you also have to run like another system, like a monitoring process or a watchdog process to kind of keep track of those two processes that they're always running, because you don't want your monitoring agent to go down, or worse, your app to go down with the monitoring agent. It just ends up in these weird states. So the centralized linked container sort of simplifies the management level. There's only one per host, so you get back kind of the resources of just kind of running a single agent. But you're sort of kind of forcing your teams into a single type of collector, a single tool, which in some cases is perfectly fine. And in a kind of just a straight Docker world, links, they're set once. Typically the process reads environment variables on startup. If that container dies, the link goes away, and you have to sort of handle that failure situation with your application containers so that they can start talking back to the monitoring agent. If you're using like service discovery or a system that can kind of help you facilitate that, it's less of an issue, but still something to consider. At a container-aware level, you've got an agent that actually understands and can kind of correlate the container metadata with the actual consumption at the host level there, and sort of give you that view into the containers. And so, what's nice about those is the configuration is typically somewhat passive. You deploy the agent, and then you deploy the containers on top of it, and these systems just treat it like a new entity. It starts reporting on it, collecting stats for it, displaying information for it. When it disappears, it also disappears from kind of the system. And depending on how you're storing your records, you have a record of whether or not it was there. But you definitely get a lot more visibility, and you can kind of see specifically what each container is kind of doing. You don't have a lot of the overhead of running multiple processes or agents. But you still have to deploy these agents, so you're still managing kind of that host level OS piece, and sort of there's that little bit of overhead. So let's get into a demo. We'll take a look at deploying monitoring agents in Rancher, and then deploying an application and sort of seeing how this all kind of comes together. We're going to be using Sysdig. We've been using Sysdig at Rancher. We looked at several solutions. And we wanted something hosted and something that just sort of worked pretty easily out of the box and gave us what we needed. So that's why we picked Sysdig. And so this is Rancher for those that haven't seen it. What we've got here are 5 hosts, 4 of which are tagged with the cloud Google in the region, and we've got 1 host in Amazon. Rancher can have hosts that span environments, and you get network connectivity. And so this is going to be our setup. So let's start by deploying monitoring. So Rancher has a concept of services, and these services kind of are small parts of a stack, which represent kind of logical functional units within your environment and your application. So the way I see this kind of deploying is we'll kind of have a stack that's the operations tools. These are tools that aren't directly related to anyone else's application, but we want to make sure they're deployed. And so what we're going to do is use Rancher Compose to deploy this Sysdig agent. And this is an agent that they provided, but the key things that we're going to be adding are these tags that describe that it's a role, is monitoring, the environment I'm deploying it to is Meetup, and that all the hosts that I'm running are Ubuntu. We have an access key that comes from Sysdig, and this is going to be pulled from an environment variable. It's a newer feature in Rancher, Rancher Compose, where we'll substitute environment variables into the template. And these are the volumes that the agent needs, but then we get down into some Rancher-specific stuff. What we're going to do here is this label, use this global label, which tells Rancher to deploy 1 container on every host. And since this is a production environment that we would care about, we sort of just want it to go onto the host. And if we add a new host, we don't really want to think about it. It's just going to install that agent on that new host for you. And then this other label here is just overriding the host name inside the container to whatever Rancher kind of names the container. So let's bring that up. I'm going to do a Rancher Compose, make this a little bigger. All right, so we'll do a Rancher Compose SP, I'll say ops tools to name my environment, or my stack, and then all of my services from this compose file will deploy to that stack. I'll give it -E and pull the environment variable from that file there. And then I'm just going to tell it to come up. So you can see here, it's now creating my services, and they're all coming up. And so let's just go see what that looks like in the UI. I now have my ops tool stack with my Sysdig agent service. And if I look at my infrastructure view, I can see now that my ops tool stack is deployed on all the hosts, and I have 1 agent running on each one. So what that looks like in Sysdig Cloud is, you give it a second, wait for everything kind of to come up, as now I have this, all my hosts show up automatically. I've tagged, I'm grouping these by the environment tag. So this is my Meetup environment. And then within that, without doing anything, I now have visibility into the various containers on the host. So I've got the Sysdig agent, I've got the Rancher networking agent, and I've got the Rancher agent. And it just kind of gives me a nice view of my host and sort of what's going on from a CPU's perspective, memory. And this is kind of a default view, and you can look at it by container. And so out of the box, without doing anything, I can see the consumption of each of the containers across the environment. The names are a little wonky, but yeah. So that's our monitoring tool is now deployed, and we're up and running, and we're configured. Now let's get to deploying our application.
Bill, there was a couple questions that came in. One was, with that global scheduling tag on the containers, does that mean when you add a host from anywhere, it would automatically populate the new Sysdig agent? Or populate the
Yes, it would.
Sysdig agent?
Yes, it would.
Okay.
Yep.
And then another question was, there was a question about the naming on those tags. So Greg had asked about if there were any plans to support Rancher labels in Sysdig in the future, and sort of Rancher names in Sysdig. I think we'll let the Sysdig guys talk about that, but I just wanted to kind of maybe clarify the naming of the container agent, the container names between the two platforms. Can you explain a little bit of what's going on there?
Yeah. So what Sysdig is doing is it's looking at essentially what the output of a Docker PS is. And so there's the container IDs and then the host name UUIDs. And so as a Rancherism, we assign the container name this long UUID, which is why it's showing up here that way. In a little bit, I'll be able to show you when we're looking at more like a metrics view. We can look at the net request count. I do have some labels applied to it, and so they do have some label support built in already that I can now grab. Here's our different labels, and then it would segment this graph based on those. So here we can see the ops tool Sysdig agent is this orange line, and then if we didn't deploy anything through a stack and a service, then it shows up as this untagged, which is the Rancher agent and probably the network instance at this point. So they do have some visibility into the segmentation for support for labels. And Chris, or do you want to jump in on that?
Yeah, I think you covered it, Bill, actually. So Sysdig supports all of the container metadata as well as currently Docker labels. So many other Docker ecosystem tools use Docker labels, and we'll pull those in automatically. We'll also pull labels from AWS if you're running on AWS, and we are adding more support for container metadata every day. So Kubernetes and Mesos are going to be coming soon, and we'll be just expanding from there.
Great, thanks. Why don't you keep going, Bill? There's a bunch of other questions. I'll just kind of keep them coming as we get a break.
Okay. So then now we're going to use deploy an application. We'll look at the Docker Compose file. Make this a little bigger. So this is a Docker Compose file. It's the demo app that they actually have, Docker has on their website. It's just a little Python Flask app that talks to Redis, increments a counter when you hit it. What we've added is a Rancher load balancer. And so this will basically be load balancing our web server. I've assigned some labels for role and app. I've also assigned scheduler affinity, so there's a soft affinity so that they won't necessarily stack on top of each other unless they have no other option. I'm also using a host label that will say only deploy it to the Google Cloud. For latency reasons, between that Amazon host and our Google host, there's like 100 millisecond latency that makes it somewhat impractical to span the application across that for demo purposes. So we'll be bringing this service up. We'll do a rancher compose p pyapp. We're going to be naming the stack pyapp. And then we're just going to tell it to bring it up. So now we go to the UI. We can see that we've got our Redis service coming up. So that came up, and then the web is coming up. And you can see here that it's linked to the Redis. Actually, we can actually get a graph view of what that looks like.
Bill, there was actually a question on that that had just come up a couple minutes ago, which was asking about whether Rancher Compose has a way of waiting for dependencies between different containers in the YAML. So when these come up, what's the start order and how is that figured out?
So Rancher Compose behaves very as close to Docker Compose as possible. And so what it's doing on an up is it looks at the links and volumes from sort of the dependencies there, and it makes decisions on what to bring up first based on those. So if you have a container that has the volumes from, it will bring up the container that's providing the volume before bringing up that container. Now, one of the challenges with this, both solutions, is that it only really brings up the container. So once it's created and enters into a running state, it considers it all good. But what that means in actual implementation and reality is, like, sometimes it takes a few seconds for your MySQL server to initialize or come up, and your web app's coming up immediately and tries to hit it and then fails. And so you kind of, in your compose files and your containers, you sort of have to do some fancy sleeping or some checks before you bring your service up, that your dependencies are available to you.
Another question that came up on sort of the same state about scheduling and a scheduler affinity was just what were the different options were around affinity. Tuan Nguyen and a few other people were asking about scheduling. So would you mind just maybe from the UI showing sort of how when you create something you define a scheduling policy?
Yeah, so when you create a service, this is a UI wrapper around kind of the compose YAML file. So you would just create new service, and then kind of what you're really going for is the scheduling. So you have the global scheduler, which is always run one up on every host, and make that easy up here. You can assign it to a specific host and say run this whole application on one host. Or you can say pick host based on labels. And so you can have a host, must, should not, must not, and sort of these set your conditions. So a must is, it absolutely has to be this way. And if we can't find something like that, we'll fail to schedule. A should is a soft requirement, like these containers shouldn't be, but if I'm running this stack on a single host, I would prefer it deploy. So it'll handle that situation. So we will stack them, but only as a last resort. And so the things you can schedule against are host labels, which are what we saw in the infrastructure view, the cloud and the region. So I can also deploy, if you have a label on a specific container, you could deploy against that or make decisions based on that. So you can maybe put like a database container and say, never deploy my web next to my database or something along that line. You can do it at a service level. With like our Elasticsearch cluster, we do it at a service level. We say, for my stack, do not deploy data nodes on the same host. And then you can also do that with a container name, like a specific container name that's useful. It can be used with services, but it's probably more useful for deploying single container values. And so you can create multiple rules. So I can say, deploy on Google, and then I could have one that said only deploy in this region. You can build complex rules. or if you want to make sure that there is only one and only one, you can deploy a global service on a specific host, but make sure there's not a container with this name or tag before you make that decision.
This is just, I think that it covers most of the question. There was a little bit of clarification asked by Enlin Zhu. He was saying, you know, is all this static, or can it be changing once it's deployed? So for instance, if I want to change the scale, or I want to change, you know, I want to add more capacity with a specific tag, things like that.
The scheduling labels, I haven't tried to edit them. I think if you take a label off a host, it'll make the correct decision. Or if you had a host that didn't have a label and you applied that label, it will, and it was global and it was looking for that, it will make that decision. But I guess we can try.
I can comment a little bit on like what aspects are dynamic. For the scheduling, basically you can add and remove.
Go ahead, Darren. You cut off there.
Sorry, cut off for a second there. So for the host labels, those are dynamic. You can add and remove them. So you know you can change that if you need to. The labels that go on containers, like we're using Docker labels, and you can't change labels on containers from Docker's perspective. So so we don't actually, once this container is deployed, we don't change the labels on it. So you can deploy new containers with new labels. That would be different. And then additionally, you can scale up and down the applications, you know, dynamically. So you can have, you know, some containers deployed with certain labels, update the service configuration, and then scale it up, and it will deploy containers with new labels. So basically, we're as dynamic as we possibly be that Docker will allow with labels.
Great. Guys, I want to, there's lots of questions coming in about things like scheduling and health checks and sort of more, you know, just generic rancher stuff. I want to keep the topic focused on monitoring, though, today as much as possible. So I'm going to sort of push most of those questions toward the end. At the very end, we'll come back and answer any deeper sort of questions about how Rancher does scheduling and monitoring and load balancing and can run behind the firewall. There's just lots coming in. There was one question that is a real quick one about what version of Rancher you're demoing here. Can you just clarify on that? Is this 0.41, 0.42?
We're running 4.2. This came out yesterday.
Great. Okay, and there was a bunch of questions about Sysdig as well that I want to get to, but maybe you can, you know, as you're going through the demo of the Pi app, would you mind showing a little bit about historical data, about how the graph scales, you know, and there's questions about whether Sysdig was only available as a cloud solution, which is not. It's also a premise. We're going to talk about that later. So a lot of questions that are coming in. We'll definitely get to all of them, but why don't we sort of maybe hit on the how to use Sysdig piece by using your Pi app example, yep. And then we can switch over to Chris.
Yeah, absolutely. So just quickly, we need to get the IP address of our web app that we've deployed. And if we visit that, if everything worked correctly. Great. So we've got our new web app, and it counts every time we hit it. So let's just see what happened in Sysdig. You can see now that the containers are deployed. Here's my Pi demo. You know, on this one, we've got agent, rancher agent. I guess we didn't get anything on that host. But you can see that the containers that were deployed recently have now sort of popped up and are now showing in the in Sysdig. And so we'll take a look at just kind of one of the metrics. We'll look at request time, and we'll start segmenting that out by stack service name. So we can see we got our Pi web app, our load balancer, and we can see basic response times. This is all, I think, fairly real time. I think there's a couple of second delay, but we can kind of see what's happening. So let's generate some traffic because we're pretty excited about this. So just going to run a little script that runs AV bench. Get the URL. So we're now just going to start hitting it with traffic. You can see that we're hitting it with traffic. And here we should start seeing that we're hitting it with traffic over time. The request counts. So we can see that we're actually hitting it with traffic, and now Sysdig is updating on a regular basis that we're actually, it's now showing that we're hitting 50 requests, 46 requests. Yeah, that's impacting our request time. So one of the things that you might want to do with this is, and something that we get asked a lot, and what we're kind of thinking about is, how would you do kind of auto scaling? And so, you have, it's sort of unique to every application and what you would consider to use, but here's what we're sort of thinking. We would pick a metric like this, a tool like this that actually monitors some stat, and so you would add an alert. We'll use the stack name, stack service name, and we're going to say when it's PyApp web, and our net request time average hits, I don't know, 3 milliseconds for at least 1 minute, and give me an alert. So we'll create that. So now we're starting to see stats coming in. Our PyWeb is in the microseconds. Yeah. So now, generate more traffic. Should be able to see the counts going up. Kind of see request time. All right, so now we're starting to see some load on the load balancer and the PyApp. So anyway, at some point you would see that, as more traffic hit this, you might see your request times go up. And so what would happen is you would get an alert, and what we would be able to do is then you'd want it to come over and you would want to scale up your service. So to do that, you would go to your web tier, and you would just set a new scale. This is a pretty lightweight Python server, and we've got a bunch of cores, 4 core boxes. We'll deploy 16 across, roughly. So we can see all of these hosts should be getting about 4 containers each. And then we see in Sysdig, traffic spike, really big spike. So now that we've scaled up and it's had some time, you can see kind of things are leveling out and stabilizing. You kind of get that. And so with this, we can also take a look at other views that see how it's impacting at a host level. There's the Meetup view. We can see, also you can see that all the containers still have popped up in here. You can take a look at this cross-section of the networking. You can see bytes in, bytes out, number of connections, request time breakdown. This one's kind of interesting. You can see what it's waiting on. Yeah, and then you also get kind of a cool traffic view. You can see, and then dive into the environment and see what's talking to what. I can make this bigger. You can kind of see all the containers, and as they load balance out. Yeah, and so that's kind of how you would deploy a monitoring agent solution in Rancher, and then deploy your applications on top of it and get visibility into the environment, and basically get kind of a lot of different views and insights into how your application's running and where you need to spend some attention to improve bottlenecks or just gain visibility and insight.
Thanks, Bill. That was great. I mean, that was very helpful to go through it in that level depth. There's a couple questions that kind of popped in as we were going. One of them was about the scaling. And when you scaled these things up, how did the load balancer know that there was additional nodes? Maybe you can just sort of touch on that briefly, if you have a second.
Yeah. So Rancher is actually, when we tell it to scale, Rancher has pretty much all of the metadata and knows pretty much where everything is in the environment, and it writes out the configuration file to our load balancing container. I think it's this LB agent. So this is a load balancing container that we've got deployed, and this is what's handling it all. And so the configuration file just gets dynamically updated from Rancher.
Is that because of the service discovery capability? Is that what's doing it? So it's registering the service, and now it's populating the IPs of the new containers?
Yeah, it's using Rancher itself, not the metadata service. But yes, it's essentially, because we know where all the containers are, we can update that configuration on the load balancer with all of the new container IPs.
Right. And then on the monitoring side, on the statistics side, the data that you have, is that it's certainly being exposed live. We saw that. Is how much historical data is kept? How do you sort of define how to keep? Is it automatically kept? What's the policy in terms of historical data?
Yeah. So it's been my experience. Like they do have this the ability to view kind of the past historical data. And it actually it's quite handy, because if something happens and you sort of get reports about it later, you can actually go back. You didn't have to actually witness the event. You can kind of go back, which is pretty cool. So, if we've got, so if we look at our network graph, so we look at our request times, and then we go back 2 hours and segment that, grab the Meetup group. And so here we kind of go back 2 hours. You can see I was practicing earlier. You got other, so you can go back and drill in. It's pretty neat. Like if you're running in AWS, you can correlate all this data back to CloudWatch metrics and get a really good view of kind of what's going on in your environment. We used that quite a bit when we were doing some early load testing. And so it looks like it goes back 2 weeks, but I'll let Chris and
yeah, so I'll jump in. This is Chris. So we actually keep your data indefinitely on the SaaS product. If you're using the on-premise version, you can kind of tune the data retention to your own needs. But for the SaaS product, we give you that real-time data, and then of course we roll the data up over time. So we're going to give you 6 hours worth of 1 second granularity, and then it rolls up to 1 minute and 10 minutes out from there. Bill, what you're looking at in the top right is kind of window presets, but you could actually jump back in time by clicking on the time range there. Yeah, so you could go back, say, 6 hours or a day or to any point in time in the past, and we're going to have all correlated together then. And what's really cool, I think, is you can even hit play then and watch a replay of your infrastructure, kind of like a DVR, or step through it in different increments of time and really understand what was going on in the past. As you said, Bill, it's really helpful for troubleshooting scenarios.
On that topic, there's a couple questions about what type of database you support for that data. Just for on-premise. So obviously for the cloud, you store it yourself. But you've mentioned for on-premise, you sort of decided users would decide for themselves what to deploy. What is just a normal any SQL database, or what do you?
Yeah, sorry. So I can clarify that. So we use Cassandra as our backend, and when you run it on-premise, we've actually packaged up our entire backend, the whole Sysdig Cloud product, into containers. So you just take our containers, deploy them. There's nothing you need to worry about in terms of storing the data yourself or figuring out how to manage that. We've done all that for you. All I was trying to say is we can configure the data retention policies on a custom basis to determine how and when you want to roll up that data if you're deploying it on-premise in your own environment.
Got it.
Does that make sense?
Yeah, it does. Yeah, there's another question that I think aligns to that you may want to cover later if we want to keep moving, but it was about what are the different kinds of alerts can be triggered, specifically alerts like email, HipChat, Slack, webhooks. So, are there other triggers and alerts that are available? What can you call out to?
Yep, that's an easy one. So we do email notifications by default. We also integrate directly with PagerDuty, and we have a pretty deep integration with PagerDuty, and then we also integrate with Amazon SNS. The Amazon SNS is pretty cool because if you're on Amazon, you can do something like what Bill just demonstrated, but actually trigger it with automatic scaling based on the SNS triggers. So that's pretty powerful, and we're going to be adding more integrations as we go. If there are any requests, throw them out, and we'll work on that.
Right. Thanks. So I think one of the questions I've seen a couple times come up is about what are the different, it's about on-premise, open source versus the cloud. So I think another would be a really good time to maybe transition to Gianluca and Chris and have them talk a little bit about the differences between the Sysdig open source product as well as the Sysdig cloud and sort of Sysdig enterprise. So Chris, I'm going to pass the ball over to Gianluca as the presenter now. But you may, if you want to talk a little bit about that as he's getting set up, that might help him in the transition.
Yeah, totally. So Sysdig, we have a couple products we create. The first is our open source tool, which is what Gianluca is going to be talking about now. Then we have our commercial tool, which is Sysdig Cloud, that's built on top of that. At a really high level, Sysdig, the open source tool, works on an individual machine. It's a command line tool that works on an individual machine and gives you really deep visibility into that individual machine. Sysdig Cloud then aggregates that data from across your whole distributed environment, aggregates it together on our backend or on your on-premise deployment, and puts the pretty charts and visualizations that you saw on top of it, as well as a bunch of intelligence and alerting and other features. So that's kind of the summary. I'm just going to kick it to Gianluca now to go into depth on what the open source technology can do, and then we'll wrap it up by kind of tying it together with Sysdig Cloud.
Hi everyone, my name is Gianluca. I work at Sysdig as a software engineer, and today we're going to talk about container troubleshooting, which is a super interesting topic. Essentially, what's the deal with container troubleshooting? As Chris mentioned earlier in his intro, seeing inside containers is not easy at all. And he covered essentially in great depth all these elements. Why? Because they are isolated, self-contained, simple, and lightweight. And so, of course, troubleshooting containers is extremely correlated to how easy it is to see inside containers. So if it's hard to see inside containers, troubleshooting is going to be a challenge. So today I want to quickly cover essentially some real-life use cases of container troubleshooting on a real infrastructure that are essentially meant to provide you with immediate value in your daily job of developer or system administrator. So let's jump into the action, and let's take a look at the infrastructure that we are working on today. The infrastructure is a simple web application that I create with Docker Compose, where I essentially have 3 tiers. One is the WordPress tier, where I'm essentially running a bunch of Docker containers from the WordPress image that are essentially running the Apache web server and serving the PHP application. Then I have a MySQL tier where I'm running a single MySQL container that, of course, all the WordPress containers will use for the persistent layer of the application. And then I have a single entry point, which is provided by NGINX. And this works essentially by having NGINX automatically discover all the WordPress instances that are running and automatically creating an NGINX configuration file to essentially load balance and proxy the traffic between all of them. This infrastructure is already up and running, so if I do a Docker PS, I can see that I have 4 WordPress containers, 1 MySQL and 1 NGINX, and if I want to, I can also curl it from my command line so I can see essentially the home page of my WordPress website. And so with this being said, what are some of the things that one is interested in monitoring this infrastructure? Usually, when I do troubleshooting, I'm interested in these 5 categories, and I want to quickly touch on the first 2. Let's start focusing on the resource usage and the network activity of this infrastructure. So let's create essentially some traffic in this infrastructure using this performance version of a traffic generator, where I'm essentially doing a bunch of curl in a bash loop every 100 milliseconds, so to keep my infrastructure up and running. And let's open a new shell where I essentially start my troubleshooting. And what is the first tool that comes to my mind for doing generic resource troubleshooting? It's of course top. So if I do top and I sort, for example, by PID, now I'm seeing all the processes in my system along with the system resources that they are consuming. For example, here I can see that I have a bunch of Apache 2 processes, which are of course the ones that are running in the different WordPress containers. And I can easily see essentially the resources that they are consuming. For example, I can see that all the Apache processes seem to consume an average of 3% of CPU, which is of course great. But when it comes to container, I have a new barrier between me and my troubleshooting tool and the process. In fact, I cannot easily see with top on which container a specific Apache process is running. So if I see that, for example, a web server is misbehaving and is consuming 100% of CPU, I have no easy way of knowing on which container this is running to know essentially what to do next, for example, for a Docker exec or something. So top, while it has been useful for many decades, is not the most ideal tool for doing resource troubleshooting in a containerized infrastructure. We can leverage, for example, some tools that Docker ships. For example, with Docker PS, I can see all the containers that are running in my system. And if I do a Docker stats and I put, for example, 2 containers, now I can see a real live resource utilization of the containers that I specify in the command line, which in this case I can see the WordPress 2 container is consuming 10% of CPU. So overall, this is a slightly better workflow than top. And if I want to drill down into a specific container, I can essentially use Docker top. And now I'm seeing just the Apache processes here that are running inside the container. And I can specify various flags, for example, with the AUX, which is the typical PS set of flags. I can see now the CPU of each process running inside the container. So overall, this is a nicer workflow. when it comes to essentially troubleshooting basic CPU, memory, and I/O usage. What happens if I'm talking about the network? If I'm talking about the network, the first tool that comes to my mind is the typical netstat, right? So if I do a netstat, I see all the connections that are happening here. But if you notice, I'm just seeing all connections on port 80. So I'm not seeing, for example, the connections that are happening between the WordPress containers and the MySQL container, because they should be on port 3306. And again, this happens because containers are isolated. So by default, each container gets its own network namespace, and so it gets a completely separate set of network connections and network interfaces that they are not visible by default using the monitoring troubleshooting tools that are running inside the host, which is why essentially here I'm not seeing any connections on port 3306. So one thing that I could do, I could essentially run a bash shell inside my MySQL container and then run netstat. But as Chris said before, on containers you don't install or your tool belt of system and monitoring troubleshooting tools, because you want to keep your container pristine, simple, and lightweight. So in this case, I'm essentially screwed. I don't have a good way to have an holistic view of all the network connections that are happening across all my containers in my system. And so at Sysdig, we worked a bit on this problem, and essentially we came up with Sysdig. What is Sysdig? Sysdig is an open source system troubleshooting tool that essentially can be thought of. You have probably all used in your life at least one TCP dump. So Sysdig wants to be what TCP dump is for your network, it wants to be for your entire system. So Sysdig works essentially by capturing system events, and it allows you to filter them in a very stateful and user-friendly way, and then it allows you to run useful scripts on them. It's completely open source. It has a nice command line interface or Curses UI, and of course, it has native support for containers. Before showing Sysdig, how does it work? The key principle of Sysdig is pretty simple. Here you have the typical architecture of your system where you have a kernel running, and then on top of the kernel you have all the applications. Some are running in a separate container, and some are running natively in the host. But regardless of where they are running, all these applications will interact the same way with the kernel, which is through the system call API. And Sysdig leverages this fact essentially by having a little kernel module that intercepts all the system calls activities that are going on among all the processes in the system, and then delivers them to the Sysdig user space application that can live natively in the host or in a completely separate, privileged, for example, Docker container in this case. And so by passively monitoring your system, we are able to essentially show you some pretty good information that are extremely valuable when doing troubleshooting. How does it work from the practical point of view? So here I have my shell, and if I do essentially a Sysdig, now I'm seeing all the system events that are happening in my system. And this, again, this is not incredibly useful. So the second item in my list was filter events. So if I do a -L, I'm brought to essentially a view where I can see all the filters that I can use to limit the scope of the events that are printed on screen. And I can filter on files, I can filter on processes, on event types, and containers. So for example, in this case, I can do Sysdig, and I can run with the filter container.name equals demo MySQL1, and now I'm just seeing the events generated by the MySQLD process inside the container with this ID and this name. So again, depending on what you are looking for, this can be very useful. Another way to interact with Sysdig is the chisel, which are scripts that I can run, and they will process the system events for me, and they will provide me a much more user-friendly output. In this case, I'm seeing, for example, the I/O activity broken down by individual file, which again is a pretty unique metric that unless you want to get your hand dirty with system tap or dtrace on Linux, if it's even available, it's pretty hard to get otherwise. Then another very good user interface for Sysdig that is extremely useful for doing troubleshooting is Sysdig. So if I run Sysdig, now all the system events essentially are collapsed into views. And here, for example, I can see all the processes in my system along with the system resources that they are consuming. And essentially, this is pretty similar to top, except for a big difference. Then now I'm seeing the container where each process is running. So I can immediately filter, for example, filter by WordPress 4, and now I'm getting all the Apache processes that are running inside this specific container, along with the system resources that they are consuming. So again, this provides you with incredible value when essentially you are troubleshooting containers. But when it really shines is if I press F2 and I go to the Views panel, and now I'm able not only to see a view of the processes, but to see essentially a view of every other system resource that is going on. All these views are customizable. For example, if I go on connections, now I'm able to see all the connections that are happening in my system and in which container they are happening. So finally, I'm able to see, as you see here, all the connections that are going on in the MySQL container and the Apache 2 in the WordPress containers is generating. So again, finally I have a view which is similar to Netstat but works across containers. And of course I can sort this by number of bytes written or number of bytes read. And this is just one of the views that we have. We have many more that are incredibly useful. For example, in the containers, I can see a view that is pretty similar to the Docker stats one, where I can see essentially all my containers along with the system resources that they are taking. But where it really shines is that I can select each entity and press enter and do what we call the drill down. And now I'm seeing just the processes running in that container. And all these columns are sortable. For example, I can sort by network, and I can see that not surprisingly, the NGINX worker process is consuming 80 kilobytes per second of network activity. So usually in a troubleshooting workflow, you will say, okay, what's going on in these 80 kilobytes per second? And with Sysdig, you can have an easy answer because by pressing, for example, F5 and going to the echo mode, I'm brought to a view where I'm seeing all the I/O buffers exchanged by the process, which in this case are all HTTP requests. In fact, I can go here and I can see that NGINX read from this connection on port HTTP, this HTTP request, which is essentially a GET HTTP request from curl, which was running in my host, and then it immediately opens another connection on this one where the IP is different, always on port 80, where this time it writes the same HTTP request by forwarding it to one of the WordPress containers. In fact, I can see that the HTTP request is the same, but we have new HTTP headers, for example, X-forwarded 4 and X-forwarded proto. And then, of course, this is followed by all the HTTP response, which is then forwarded back to the curl process. So again, this is incredibly useful because by passively sitting in a separate container and passively looking at all the system activity, I'm able to provide this great level of visibility that is very valuable when it comes to troubleshooting, especially in production where you don't want to mess with your containers by installing stuff or doing essentially other things that might jeopardize the integrity of the container. And then we have other views. For example, in my list there was the files. So I can click on the files view, and now I'm seeing all the files activity broken down by container and by file, and I can, for example, sort it by number of bytes written, and now I'm seeing that all the WordPress containers are doing a constant amount of file write to the access.log file. And again, once again, if I use the echo mode, now I'm seeing all the content that Apache is logging to the file. So with this regard, essentially, Sysdig and Sysdig, they work as a cross-container tail or grep for your system, which I find it to be pretty useful and essentially unique. And then all the other views are worth exploring. For example, another one that I use a lot is the spy users, where I'm seeing all the processes executed in the system from which user and from which container, which in this case you can see that I have about 10 instances of curl running every second, which was my, as I said before, my poor man's version of an HTTP traffic generator. And so essentially, with this being said, this concludes my very quickly overview of Sysdig. There's much more that could be said, so if you're interested in the open source product, feel free to go on our website or look on other videos on YouTube, because this was just the very tip of the iceberg. There's much more that Sysdig can do if you are a developer or sysadmin. And with this being said, I'll kick it back to Chris.
Hey, Gianluca, this is Shannon. Actually, there was a question that came, and it was asking about the performance impact, and it was from Enlin Zhu. He said, you know, what is the performance impact if every system call is being interacted? You know, how scalable is this within a host? Maybe you can chat about that, or Chris, if you want to talk about the high level.
Yeah, absolutely. So essentially, the performance overhead can be broken down in two parts. One is the overhead done by the capturing engine that captures the system call, and this is incredibly small. We've done a lot of work to make the driver as lightweight as possible. In fact, we don't copy information around. We keep everything in a ring buffer, which is automatically shared with user space. So with that regard, the overhead of the driver is extremely minimal. Then when it comes to the Sysdig application, the overhead heavily depends on what one can do. So if you run a lightweight chisel, or if you just run a normal filter, the overhead is pretty negligible. For the Sysdig user space application, we are talking about a few percentage of CPU for a few percentage of CPU usage. But instead, if I choose to do something that is more intensive, for example, one feature that I didn't show here was that with Sysdig, exactly like TCP dump, you can choose to dump all the system events to a trace file. So if I go on a system which is incredibly busy and I choose to start writing on disk all the system activity with the zlib compression enabled, now Sysdig is easily going to a few dozen% of CPU, which is expected, of course, because you are doing something more intensive and that work has to be done. Another thing to say is that this same technology is the same one which is at the core of Sysdig Cloud. And for our Sysdig Cloud agent, we have done extremely heavy optimizations. So if you use it, you can expect your system overhead to be just of a few point of CPU usage, even in the most hostile conditions.
Great. There's another question that I think would be interesting to discuss was, you know, can Sysdig monitor, and this goes for both the open source and the cloud. Damir asked if it could simultaneously monitor containerized and classic infrastructure, like in a case that some services are running outside of a container, for example, in a NoSQL cluster.
Yeah, the short answer is yes, absolutely. So both tools will concurrently monitor everything running on the machine that they're installed on. So whether that's in a container, outside of a container, on bare metal, in a VM, in the cloud, it doesn't matter. You install Sysdig, you're going to see everything.
Great. All right. Chris, are you the presenter now? Do you need me to switch you over, or you're now the presenter?
I believe I am. Hopefully my screen is coming through. Let me know if that's not the case.
Great. Well, just real quickly as a time check, we're at about an hour and a half now into the content. So there's still quite a few questions that have come on, and quite a few for you, Chris. But why don't I let you sort of go through your content, and then we'll sort of keep the questions for a minute to the end.
That sounds great. I will keep my content really quick. I know we're running long here. I just wanted to show a couple things in Sysdig Cloud that Bill didn't get to cover. The first is this view here, which we call the topology view or the map view. Bill showed a little bit of it. I want to show what this looks like on a demo environment we have running on AWS here and explain what's going on. So hopefully from Gianluca's little background there, you have an idea of the depth of data that we're able to collect from your machine on a local machine. And this is now kind of a nice demonstration of what we're able to do when we aggregate that data across a distributed environment. So here we can see I've got my load balancers on AWS that are distributing traffic out to my front end where I have 3 servers, and then data is going out to my my data tier and the various database and caching technologies I'm using. But what I can do now is start to zoom in, and we like to call this Google Maps for your infrastructure because you can kind of zoom in like a map. I now see I've actually got 3 EC2 instances running within my front end here, and then I can go all the way inside this instance and see the individual processes that are running, like Python here. I'm going to pause this so it's not jumping around too much. And then as well as the actual containers that are running. So you'll see this looks very similar to the environment that Gianluca was just demoing in, but now we get kind of a visual representation of it. So we can see HA proxy distributing load out to my, my WordPress containers, and we can see all the way inside and see the processes running in those containers. This is really the kind of the network and system level information. What we're looking at here is CPU usage and memory usage, although we could overlay any metric on this. The one other thing I want to touch on is all the other types of metrics that we're able to pull from a containerized environment. So up at the top here, we see CPU by container name, container image. This is the kind of data you're going to get from any standard monitoring tool, or even monitoring tools that that have added support for Docker and containers. We really want to take that one step further and give you application level metrics straight out of the box. So just by installing the Sysdig container into your environment, we're going to automatically detect all the applications that are running and start pulling metrics from those. So Bill showed some of the HTTP data that we can pull. Of course, the application metrics you want for your environment are going to depend on your environment and the applications that you're running. We support dozens, I think it's over 100 different applications at this point, and we can also import custom metrics from JMX or StatsD. But this is just an example of looking at the Cassandra container and the types of metrics we can pull there. So pulling metrics from the JVM, the underlying Java virtual machine, as well as the Cassandra application itself. And to kind of reinforce what this looks like, if I zoom in on the Cassandra machine here, it's really important to note, you can see here the Cassandra container is running with just a single process in it. So this is a totally pristine Cassandra container pulled down right off the Docker repo. And over here is Sysdig actually running in its own container. And we're able to, from over here, kind of poke a hole in that Cassandra container and automatically collect the metrics out of it. The final thing I want to show here is kind of hinting at the direction we're going with this and adding support for all different orchestration tools. And you may remember when Bill zoomed in on the Rancher layout, the network view was pretty hard to understand because Rancher, like all orchestration tools and scheduling tools, is going to distribute your containers in a balanced way across your environment. This is really powerful, but it can also make it hard to look at things from an application point of view. So what you're seeing here is actually a similarly scheduled and orchestrated environment, in this case running on AWS. But here, instead of looking at it from a physical structure, we're looking at this from a semantic or application level structure, a logical structure. So now I can see my ELBs are pushing out load to my Java service and my WordPress service, and those are connecting out to the data services. And when I zoom in here on my WordPress service, I see I've actually got 3 containers running within that service. Now, these containers could be, and in fact are, running on entirely different EC2 instances. They're scattered around the cloud. But with that understanding of the kind of container metadata and the orchestration metadata, we're starting to be able to give you a monitoring experience that's really focused on the application and the services that you're running, if you want it. So with that, let me pull up and yeah, open the floor for questions.
Great. Yeah, thanks, Chris. I think that's really cool. Okay, so lots of different questions have come in. Let me start with one that Abhijit asked. He's asked if you could monitor container-specific processes and ports with Sysdig. I think we've covered this, but if not, feel free to jump in and just go into that in more depth. Do you want to?
Yeah, I'll answer that really quickly. Yeah, the answer is yes. One of the really powerful things about Sysdig, as hopefully you've seen from the various demos, is the depth of data we can get. We can absolutely go down to the process level and the port level, and also let you configure alerts that way. So you could configure an alert on a specific port or a specific process if you wanted to.
Great. And really, I think Abhijit had asked earlier a question of whether his application, his application is not, created in microservices, but just as a very, he's using Rancher to deploy a very typical normal application. There's no reason that you can't monitor that as well. so I assume, but feel free to
Yep,
comment
of course,
on that.
yeah. Yep, we'll give you a first-class monitoring experience with a lot of the features you've seen here, all of the features you've seen here, whether or not you're running in containers. So yes, absolutely.
Okay, and another a little bit more detail. Paul Thonis was asking whether Sysdig has an API that he can use to fill his own graphs, or is he required to use the Sysdig dashboards after he's deployed? So can you pull? There was another question that sort of asked, can I push things to Zabbix? I think as I saw another one someone had asked. So maybe you could talk a little bit about that integration, the API, pulling data, any of those kind of content.
Yeah, totally. So this is really important to us, and we do have an API. It goes both ways. So you can push data into Sysdig Cloud from any environment. The easiest way is using a stats protocol like Statistic. In terms of exposing information out, though, we do have an API. The whole Sysdig Cloud front end, this whole browser-based UI that you're looking at, was built on top of that API. We're in the process right now of making various of that API public, documenting them and cleaning them up for public consumption. We actually just released public support for the API around alerting. So you can create and configure alerts through API, which makes that deployment process even more streamlined. And we are making the metrics export API available for our customers on kind of a beta level now, and we'll be opening that up publicly soon. So yes, absolutely, we will be supporting that.
Okay, great. And then the question about Zabbix was from Stephen McCaffrey. He just asked if the monitoring can be forwarded to Zabbix. I don't know if that's a common question you guys get, but maybe you can touch on that.
Yeah, we don't have any of our customers actually doing that exact thing right now. We don't have a specific integration with Zabbix, but again, through the API that we expose, you could pump those metrics wherever you wanted.
Great. And another one that sort of asked about integration was from Kevin McGrath, and Kevin asked if Sysdig could be integrated into an existing enterprise portal. So, also how you would hook into existing monitoring and event management systems. So, I don't know if you want to elaborate a little bit more on that in terms of hooking the UI into a portal possibly, or just, working with other monitoring and event management systems.
Yeah, so we, in terms of event management, we are currently, the primary integration is with PagerDuty, so that's kind of the central hub that we work with for the notification and events coming from Sysdig. We will be adding event management into Sysdig, so we'll be able to consume events from other technologies you might be using. In terms of integrating the UI, I'm not sure exactly where the question's going there. But one thing we are working on is adding support for various single sign-on services, so that if you're using this within an enterprise, you wouldn't have to use our identity management process, but rather could use your enterprise identity management tooling to log into Sysdig.
Great. There was a question from Kevin, different Kevin, that asked if the Sysdig detailed data, like the echo views showing what commands are being run, could be recorded and played back, drilled into later, or is it just real time?
Yeah, so the amount of data that's captured by Sysdig technology, the open source tool on a local host, is quite frankly tremendous. It's massive. So with Sysdig Cloud, what we do is try to kind of scrape out the most important performance and troubleshooting related information that we then aggregate together and let you put into dashboards and rewind and replay. We have actually managed to get a fair amount of that kind of Sysdig system level data into here. I'll show you a little bit of it. You can see here some of the different system views that we have pre-built here for you. So you can do something like explore your file system within a host, and even get down into individual containers and look at the file system within a container, which is really hard to do with kind of typical system inspection tooling in a container. We're going to show you the top processes, so you can do something like Gianluca was doing with running top, but essentially using Sysdig to dig into an individual machine. And then there's, I believe, other file things we can do. Yeah, in any case, we got a ton of system metrics that we're going to be pulling through for you. It's also worth noting within the open source tool, Gianluca touched on this a little bit, but one of the most powerful features of it is the fact that you can record a trace file of your system. So by using the open source tool, if you see something's going on in your machine or if you want to automatically trigger it, you essentially dump everything into a trace file, which you can then pull off that troubled machine, pull it onto your local laptop or onto a nice clean instance somewhere else, and dig into it and have that kind of 100% snapshot, that 100% recording of everything that happened on a machine at a point in time. You can also even trigger one of those Sysdig captures remotely if you're using Sysdig Cloud by clicking the Sysdig capture button to trigger a capture on any remote machine.
Great. I think that covers. Yeah, that's very helpful. There was a couple questions about Rancher and Sysdig together, and this one was for you, Chris. It was from Greg Weingard. I hope I'm saying that right. Greg was asking for the on-premise implementation of Sysdig. Are there any plans for this to be hosted, deployed onto, or via something like Rancher, as opposed to now, where requiring a separate host for aggregation? Love the product, but the replicated setup is really becoming a bugbear for me, was his comment. So anything you could talk to there about implementing Sysdig itself as sort of a as like a compose file or as a blueprint that could be brought up as a set of containers?
Yeah, I think that's an awesome idea, and we would love to work with the Rancher team to see if we could deploy it through Rancher. I mean, the deployment process that we witnessed Bill doing earlier today kind of blew me away. I think that's awesome, and it makes the management of your environment super easy. And if we could get Sysdig Cloud deployed that way as well, that'd be great. And I don't imagine it would be that hard. So I didn't catch you and ask that question right here, but let's follow up offline and we can talk about that. And yeah, love that kind of feedback, and that's a direction we're very open to moving in.
Yeah, there's another one that was sort of in the same vein, Chris, and it was from Abhijit, and he was just saying, how do Rancher and Sysdig work with each other? If the MySQL process dies inside of a container, but Rancher maybe hasn't discovered that, could I drill in and find it out from Sysdig and then maybe restart my container? So just at a high level, Abhijit, I think what Bill was showing today was kind of a very manual approach to these two systems working together, right? He was monitoring the service, saw it, took an action based on something. But one of the exciting things as we've started using Sysdig here at Rancher and have a ton of customers who really like it as well is sort of this type of, as we've been working on things like auto scaling and having triggers for things like our health checks. We could definitely we're definitely looking at how tools like Sysdig can call triggers in Rancher to then take actions, and that's an area that Chris and I have talked about, and we think there's definitely a lot of excitement about that type of integration, so that standard calls out to systems like Rancher from systems like Sysdig can enable monitoring tools to very quickly talk to the orchestrators and help the orchestrators solve problems. So I think it's a very obvious synergy that's sort of developing, and not surprisingly at this state, a lot of this is still being done manually or being done by teams using scripting and by using triggers and then writing scripts to do things. But as stuff becomes more standard, I think that's exactly the direction that product teams like ours here at Rancher and Chris, I don't want to speak for you, but Chris are looking at, is how to leverage this data more valuably.
Yeah, I think you said that perfectly, Shannon. We're really excited about that.
Yeah, and then there was one other question that I thought would be worth sort of tackling before we moved on from here, and it was it was about let me just pull it up here. It was the scaling of Sysdig Cloud. So as the number of the number of nodes becomes really high, and you start to see tens, hundreds, even thousands of containers. What kind of search and visibility tools are there? I think you've already showed us some nice stuff on the visibility side, but maybe anything you can show us in terms of search would be maybe useful as well.
In terms of search, sorry, is that what you're asking?
Being able to search and find a specific container that you want to discover. And when you start talking about thousands, how do you find and manage all of these things? So it looks like search is pretty well integrated to the whole platform from our benchmarks?
Yeah, so we've got search everywhere. We have customers running with thousands of nodes on the product now, and there are a couple ways that we manage that scale. One of the most valuable ways is with search, and so I can do something like search WordPress here, and this is just going to show me my WordPress containers then. If you had more specific names, you could zoom into a very specific cluster of containers or a specific type of image. On top of that, this tagging functionality that Bill hinted at a bit is really pervasive throughout the product and helps you with your scaling. So a well-tagged infrastructure is going to help you manage a surprisingly large infrastructure with a surprising amount of ease. And we support kind of an unlimited number of tags in a hierarchy, so you can kind of dig down into your system by whatever method you want. And those tags, we're gonna make it as automated as possible. So we're gonna, I mentioned this earlier, but we're gonna be pulling your tags from a bunch of different sources, from AWS to Docker to the custom tags you apply to things like Rancher. So I guess in summary, the tool really is designed for high-scale environments and making it easy to manage when you've got a huge number of containers, and especially when they're really dynamic and going up and down, because that's where a lot of the management gets really complex. And by making a lot of the support automatic, we try and make that simpler. So, for example, when as long as you've got your tagging configured, if a new container spins up, even if it's only up for a couple seconds, we're automatically going to apply the right alerting configuration policies to it. We're going to drop it into the dashboards that you have configured, and all of this just from having our container on the machine running with the rest of your containers.
Awesome. This sounds great, guys. I think that covers most of the general questions that have come in. I want to switch gears now really quickly and jump back to Darren to talk about just some of the latest enhancements to Rancher. I know we're now at about an hour and 45 minutes, and we've got still amazingly like more than 70–80% of the people who attended are still on. So thanks for everyone who's sticking in and participating so long in this meetup.
And Shannon, actually, real quick before I give up the screen share here, just to close it out on the Sysdig side. If anyone wants to try this stuff, it's out there. Sysdig is open source. Check it out at sysdig.org, and you can sign up for a free trial of Sysdig Cloud on sysdig.com. And anyone who mentions this meetup, we're going to give a special 20% off of Sysdig Cloud. So come talk to us. We'd love to talk to you and learn more about your challenges and how we can help you out. And thanks again, Shannon and the Rancher team, for having us here today. This was awesome.
Yeah, absolutely, Chris. Thank you. Thanks, Gianluca, so much for coming. There was a funny question came in. Brian Baird just said, "What if I bought this yesterday?" So I just bought this yesterday, and I'm using Rancher. And do I still get the 20% discount? So I'll let you take it up with him, maybe.
For sure, we'd love to get you the discount. Let's get in touch after the call.
Awesome. Okay, guys, this is all fantastic, and thanks so much for putting together so much hard work, Bill, Gianluca, Chris. I know the guys worked really hard on some of these demos, and they worked out really nicely today. So thank you, guys. I'm going to transfer the conversation. We'll come back. There's still some questions, but I wanted to jump over to Darren for a minute. So Darren, I'm going to make you the presenter. Actually,
Sorry,
do
Shannon,
you want me to make?
Do you want to show the slide of the features, and then after that, then I'll do a demo.
No problem. Okay, so I am now the presenter again, and so typically we sort of, as we're wrapping up this, for a lot of people who attend these meetups every month, we just want to cover the latest enhancements from the last few releases that have come out since in the last month on Rancher. So this month we've had 3 releases that had new features in them: 0.38, 40, and 41. And I guess 42 dropped yesterday, so if there's anything about 42 you want to hit on as well, Darren, be my guest. But Darren's just going to walk through this and answer any questions there are about some of the new features, and if there's maybe show a few of these things if you want to, Darren.
All right. Yes, I'll kind of I'm going to run through this list, just kind of explain what all these various features are, and then I just wanted to demo 2 of them really quickly. Try to keep this not too long, because it's going pretty long. But so in the 0.38, I'll start at the very bottom. Essentially, in the 0.38 release, One of the major features that we added was support for poll, and that basically goes in line with the Docker compose poll command. So we support the poll command too, but it's it's a little fancier in that we look at like the scheduling tags of your service and figure out where we should pull the images, or we have different policies on if you want to only pull images where they already exist, or if you want to like pull it on all servers, so it will basically pre-stage that image so that you can get like faster deployments. That feature I'll actually demo. So we improved this has been an ongoing effort to make the Rancher server to be able to install it with no internet access. So in that release, one of the things we did was we made it such that we're packaging the UI completely. Before we were serving up the UI from the CDN. Now it's basically in the release now. And then we did some fixes around the stats collection. So in version 40, we added support for uploading the Docker Compose file and Rancher Compose files through the UI. So before that was just a CLI feature. You had to run it from the Rancher Compose CLI. Now you can just, when you create a new stack, you can just specify those files. Additionally, we added the admin dashboard, and this has been a really helpful thing for users. Sometimes Rancher's running slow, or you don't know what's going on with Rancher. Like it seems like it's doing things. You look at the logs and you don't quite understand what's going on. So we added this feature into the admin dashboard that you can see all the processes, and I can kind of show that a little bit too when I demo. So you can see what's going on in Rancher, and this has really helped users, especially users who have been upgrading for a very long time, since like version .20 or something, because there might have been some crops left around in the system or bugs from older releases as we've been going through beta and everything. So this has really helped people kind of make sure that their system is running healthy. We had a generic machine UI support. Basically what that means is before we had I think about 4 or 5 drivers per machine that we did kind of an optimized UI for, but there were still various other drivers that we supported through the API, but they weren't in the UI. And now we have that support in the UI for basically everything that Docker Machine currently supports. And the last feature, so in 0.4.1 we added support for selectors, and I'll demo that because it's more of an advanced feature, but it's really powerful. And then Rancher Compose support for interpolating variables. What that means is in the Docker Compose file, you can put like what looks like a shell variable, and then we'll replace it with the value either from the current environment or from like an answer file. Essentially, this is a feature that's going into Docker Compose 1.5, which will be released shortly. But we basically backported that feature into Rancher Compose through Loop Compose. So you know how you can just basically put variables anywhere, and that really helps people with, like, let's say just like you want to make the image tag a variable. So if you want to, like, version 1, version 2, you just make that a variable. You keep the same template, and then change it just through the environment. Version 42 came out just yesterday. The major feature in that one is actually user metadata. Like, we have a metadata service, and we now allow you to add arbitrary key value pairs, or basically any structured data, so that when you deploy your application, you can attach a bunch of metadata that when your container comes up, you can read it to do various things. It really helps with, like, configuration management and whatnot. So, Shannon, if you want to make me the presenter, I'll demo.
Yeah, real quickly though, there was a question that came up about Ldap support, if we were adding Ldap support, which I think which was added in like 0.34. So I thought maybe, just that. There was another question about sort of the upgrade path. Daniel Pryor asked if there was a timeline for stabilizing the upgrade path and having the upgrades be sort of supported, or when GA is coming. So maybe I'll just talk really quickly on those. So on the Ldap side, we added that about a month and a half ago. So if you missed it, it was in an earlier release, but you can configure it from the admin page on any of the newer releases, so 38, 40, or anything from about 34 onward. You should be able to set up and configure a number of different authentication systems for Rancher, and including, we've always supported GitHub for auth, but we also have now an database if you want to use that yourself, or you can connect to Ldap or AD. The other question about sort of the upgrade path is, we've certainly done a lot to try and make the upgrades simple for users that are on these in the beta, but obviously when we go GA, Rancher will ship we'll continue to have the open source versions, obviously, which will probably slow down slightly in terms of pace, but will continue to be the bleeding edge of development around Rancher. And then we'll have an enterprise release that we provide, which is sort of the commercial supported version from Rancher, which is which will have a stable upgrade path that we test and validate for specific versions and provide support around. So that we obviously do a lot of work to make the upgrades work now and to make them stable. But if you're jumping a whole bunch of versions because of the pace of the development, we'll definitely be making that easier going forward. Okay, I'm going to make you the question. I am going to, the presenter, and Darren, I'll let you go forward from here. Give me 1 second. There you go. You should be the presenter now.
All right. Okay, so you should see my there's a demo environment set up here. So what I'm going to go through is actually demo selectors, and this is a little bit more of an advanced feature. So I'll do my best to explain it, especially for people. I think it's a good amount of people. Maybe this might be their first time seeing Rancher. But so what we have here is what I'm going to do is I'm just going to deploy a simple load balancer with a container behind it. So I'm going to go into this. I'm going to do this from the command line using a Docker Compose file. So if I look at this Docker Compose file, what we have here is we have this load balancer. This is like kind of the simplest way you can define a load balancer. Our load balancer really has a lot of features like hostname routing, SSL termination. So this configuration can actually get much larger, but this is kind of like the simplest kind of hello world load balancer. And basically what we have here is we have a load balancer that's listening on port 80, and it's load balancing to port 80 of the container. And then we're linking it to Nginx, which basically means this is the load balancer target. So this is how load balancing has always been set up. And this is let me launch this now. So I'm going to run Rancher Compose up. I'm going to put the -d flag, which just means run it in the background once it's up. So we can see this application is coming up here. So we have a load balancer. It's pointed to Nginx. If I go, I can look at this little graph view here. You can see I have a load balancer with one container. So this is kind of like a static, not a static configuration, but it's like it's a little bit more hard-coded. So it's like if I want, let's say I added a new service, this is my new PHP service that I wanted to put behind the load balancer. I then have to go and change the load balancer to add like PHP. So in this approach that we have here, it's the two things are kind of tied together a little more closely, where you have like the load balancer being kind of defined in configuration and configured by the same person who's deploying the application. So this causes a little bit of problems for users because load balancers, because they use a public port and IP, is kind of like a scarce resource, or scarce resource. And like I can have, I can spin up hundreds of containers, but I might only have like, let's say 2 physical servers, and so there's only so many load balancers I can set up because there's only so many port 80s. So what we're doing with selectors is we can make this a little bit more detached and dynamic. And so what I'm going to do is I'm going to switch over to this other definition here, which is another Docker Compose file. I'll show you what this is now we have this load balancer. Basic same configuration, we say port 80 to port 80, but we're going to link it to this service, which is selector-based. And so what this is actually it's kind of an empty service that's a placeholder that we put the selector here, and it says, okay, this service actually should be any container that just has this tag on it called LD true. So if I go, let me go and create this. So if I say Rancher Compose up, I go back to the UI here, go back to my stacks. So it's gone and it's created this stack here where I have this load balancer which connects to the selector, but there's no containers in. So this selector, as I said before, what it means is automatically add any container you can find that has this label on it. So now what I can do is I can have a completely unrelated project. So here I have this other Docker Compose file, and let's say this is, my PHP app here. So someone, is deploying their application, instead of them having to have like kind of linking the load balancer directly to their application, they can instead just add a label on it to say like LD true. So what happens is now when I go and I bring up this service, I go back to the UI. Let me go to the stacks here. So you'll see like I created this new stack called container, which just has one service, which is called my PHP app. So I just have this one stack. It has an application in it. But since I have this selector tag, basically what it will do is if I go back to this load balancer, you can see that container is now in there. So this makes it like it provides kind of one level of indirection, but it makes it more flexible such that you can kind of define your own like load balancer service. It's almost like you're creating your own ELB, and then people can deploy applications independent. And this works actually for all services. This is not just like tied specifically to load balancers, but this is a great use case for it. So someone can go and anyone can deploy any application and just automatically gets discovered and added to the load balancer. And in future releases, what we're working on is we're going to make this even more powerful, such that in here you can actually define like what host name routing rules and whatnot that you want. So you can really decouple these two things with the load balancer, because we're trying to, what we've gotten requests from users is they kind of want to be able to have like load balancers managed by a different, like, kind of like a different group or something, has a little bit more view to the infrastructure, and then just leave the applications deployments more to the app team. And so we're making that more and more possible with the selectors. Selectors are actually really powerful. You can do a lot of things with them. The selector, the syntax is actually, I'll refer you to the documentation. Like if you go to docsrancher.com, we have this section for labels, which defines all the different labels that are available. But it goes through the whole how selectors work. But you can basically say like not equal, or you can do in, and basically, well, here's all the ones like equals, not equals. Just look for that tag, look for it in that or not in. And so with those various things, you can actually do kind of a pretty complicated selection.
Awesome. That's really cool,
So,
man. Thank you for sharing that.
Okay, now let me just show the poll real quick. This is just like a really simple one. So Rancher Compose poll. So if you say Rancher Compose poll, this is very similar to the Docker Compose poll. But basically, this is just going to go and, like, I'm using the image Nginx, so it's going to go and it's going to pull that on all of these servers. So this is great for if you want to pre-stage images in an environment, or a lot of times for like development and CI, you end up using like the latest tag. So for environments like that, if you deploy a container, you want to pull the latest before you deploy the new one. So you can basically run a pull command. This is actually in our rolling upgrade. You can specify pull in there, and that will basically, while doing the rolling upgrade, before we upgrade, we do a pull. So this really helps people who are using the latest tag. Just other things, since we mentioned it, it was brought up, kind of about Ldap or whatever. That is just in the normal. So if you just go to admin access control, so we now have, we had Ldap we added this a while ago. But basically, here's all the various Ldap settings. So Ldap works, Active Directory. Ldap is kind of a beast in itself, and so we're continuing to enhance this and make it more flexible for various different types of setups of how you do Ldap. So, like, So we're continuing to enhance this, but this covers most basic use cases and an Active Directory, of course.
Oh, yeah.
Okay.
Anything else you want to cover, Darren?
I think that was mostly it. I can show let me just show this really quickly. Let's see if I say like, let me show the admin processes just really fast, because it's just a really useful thing to troubleshoot a system. So if I go and I say scale my PHP app to, let's say, 3, so that's going to start scaling. On this page here, you'll see like this is the stuff that's actually going in Rancher right now. Well, it came up and went away really quickly. I think it's probably already done. But you can go here and you can click and see what are all the processes, what's running. This is stuff that happened in the past. But this running tab basically kind of gives you an overview of the system. Sometimes you'll see like, oh, this task has been hung for like 2 days or something. So it just really helps in seeing what's going on in Rancher.
Cool.
But yeah,
yeah, there was a couple questions that came in that I think might be worthwhile just kind of touching on really quickly before we wrap up today. One of them is actually kind of a broader question that Kenny Wagner asked, and Chris, it kind of applies to you guys as well. But Kenny is with a service provider, and he's asking about, if they're providing services to multiple customers, do Rancher and/or Sysdig Cloud support tenant isolation? So customer A can't view customer B's resources. Support of customer/tenant role-based access control. So, Darren, maybe you just talk for a second about isolation in Rancher, and then Chris, if you want to touch on that, you're welcome to as well.
Yeah, so right now the isolation in Rancher is basically done through this concept of environment. So you go and you can create more environments. So if I just go and add an environment here, just call this like test 1. Let's see. So if I go into test 1, so basically I don't have authentication turned on. I can go to a different environment where I can show you authentication. But the basic idea. Oh wait, I can't log in. I'm not logged into GitHub. Sorry about that. But the basic idea here with the environment is that the environment owns the resources. So if I go back to the kind of the default environment that I have here, so it owns basically all these hosts and all the application, and this is scoped to whoever has access to the environment. So if you're using Ldap or GitHub, you can authorize different groups or users through those systems that they can access this environment. So if I create other environments, I can have different users who own those. So the system is multi-tenant in that fashion, and then we're continuing to increase our RBAC support. We have just some basic profiles right now of like when you add a user, they could be like an admin, member, or a read-only account. But we'll continue to enhance that and add kind of more configurable profiles so you can define at a more granular level what people are allowed to do and assign them to those policies.
Yeah, Chris, do you want to talk a little bit about multi-tenancy in Sysdig Cloud?
Yeah, sure. So right now we don't support any multi-tenancy within the product. So you would be creating different accounts for your different users, or they would be able to see the same information. This has been a really highly requested feature, though, and something we're really interested in working on. So that certainly will be coming at some point, hopefully sooner rather than later. And if you are interested in becoming a Sysdig Cloud customer, or especially if you do end up becoming a Sysdig Cloud customer, would love to kind of get your feedback on exactly what you're looking for there, and we could probably build exactly what you need.
Awesome. There was one other question, Chris, for you that had came in that I didn't get addressed earlier. I just saw it. It was, is there a way to export the metrics from the open source Sysdig tool into a TSDB? So some kind of a TSDB that you can pull from? I don't know if you were
I'm assuming TSDB means time series database. So we've seen people come up with some kind of some of their own plugins to export data out of Sysdig. There's nothing built into the open source tool besides the ability to write to a trace file, which is going to pump all of the data there. And a lot of the hard work that we've done in the Sysdig Cloud Agent is the work of translating that fire hose of data, of system call data, into nice time series, with 1 second data granularity, so that we can pump it back to our back end. That capability for now is closed sourced and what you're buying with the Sysdig Cloud tool. But again, it's an open source tool. If it's something you're interested in working on, we'd love to hear more about it, and we might even be able to provide you some support and help in kind of expanding the capabilities of the open source tool there. Cool.
There was another question, and Ludwig said, great, that's what he was looking for. There was another question that came in from Virgil that goes to you, Darren, and it was about isolation, kind of to that thing. And he was asking if there's any way to separate containers hosted in the same environment. Even if it's not very useful in VM hosts, it could be very useful on physical machines used as Rancher hosts. So if you wanted to separate VMs hosted on the same host, what's the best approach to doing that?
Well, I think,
sorry, wanted to separate containers hosted on the same host.
Yeah, so today basically when you deploy containers in an environment, we create one network, and all containers have access to each other in that network, and there's no isolation from each other. So what's coming in Docker 1.9 is the first-class network support, and so once Docker 1.9 comes out and they have the concept of networks, basically we will have the ability to create networks, and the containers will live in different networks, and then they'll be isolated that way. But right now we're just basically creating one network. I'll tell you, already under the hood, the way Rancher is already structured is from day one, we kind of already had this in mind and support and everything, but it was more of a, we've always very much embraced the Docker native experience, and so we didn't have a way to really describe networks in a way that would be, we didn't want it to be just 100% Rancher specific. So it's really, this is coming after 1.9 is released. Honestly, with 1.9 we have a lot of really cool features coming, but so you'll see that at the, in that time frame.
Awesome. All right, guys. Thank you so much, Darren. And just to wrap up, I think we've covered a lot of stuff today. Anyone who's interested and would like to get more involved with Rancher as well, you can join the beta just by going to rancher.com or info.rancher.com/beta and sign up. The beta is free. Rancher obviously is available on GitHub, but if you want to get support and get some help, feel free to come and join the beta, and you'll get access to a lot of help from our team. We also have our, on GitHub, you can get access to obviously the software for both Rancher and Rancher OS. We're going to be making some big announcements about Rancher OS in the next couple days as well, so stay tuned on what we're doing there. And definitely, feel free to get involved, file issues, let us know if you have any questions. You can also find a lot at forums and docs.rancher, so forums.rancher, docs.rancher if you need any help. Those are great resources. Otherwise, I want to especially thank our guests from Sysdig. Chris, Gianluca, it was great having you on today's call and sharing so much about how to actually put containers into production with the kind of monitoring necessary. So thank you very much for attending today's discussion. Bill, thank you very much, and Darren, thanks so much for working on these demos and sharing. Bill, especially the process that you went through in deploying and building out container monitoring for our platform here at Rancher and what we use for all of our internal systems. And we use Sysdig to monitor not only our Docker workloads, but actually our Rancher implementations as well. So it's a really powerful tool that we're big fans of. Altogether, thanks everyone for attending. It was great seeing so many people and so many of you that stayed more than 2 hours and kept asking all these great questions. So thanks a lot. Our next meetup will be in November. So looking forward to seeing some of you there. Have a great day.